All right, here we go. Now we're on to lesson 3. This is rates, starting with page 31 all the way to page 37. As we do this lesson, remember the question, how do you use equivalent rates in the real world? Okay. There are 2 goals for this lesson. The first one is to find a unit rate, and the second one is to find a unit price. Okay. Remember, guys, I'm copying this right out of the book. So if you can't read my writing, I know it's not the best of writings, but it's okay, I guess. It's not too bad. The vocabulary words for this lesson are the following. You have rate, unit rate, and then unit price. Okay. As I wrote here, please use the book definition or the glossary. Please don't use the internet unless you know what you're looking for, because sometimes the internet can be a little confusing. All right. All right. So on we go. Goal number 1. Again, please, we're doing this Cornell note style. Okay. Goal number 1. Find a unit rate. All right, before we go any further, I do want to define some things. Before, in the other lesson, we worked with ratios. A ratio is, let me just remind you what a quick definition of it. Let me give you a quick one. God, I can't speak tonight. A ratio basically compares 2 quantities using the same units. Okay? So there's a relationship. Okay, I'm going to put that down. There's a relationship of some kind. Now, guys, depending on where you look, you're going to get different definitions for ratios and rates. So if you have your own that works for you, that's fine. Let me give you somewhere to start, though. So let me give you an example of this. 3 dogs for every 1 kitten. Now, you're comparing 2 different quantities, right? How are they the same units? In this case, you're talking about maybe pets. The category could be animals, but you're still comparing the same kind of units. Okay? 3 dogs to 1 kitten. Another example would be 1 girl for every 3 boys. Again, you could be talking about students. But it comes down to the same kind of idea, same unit, same category, or same unit. All right, but now we're dealing with rate. Okay? Rates are a little easier to identify. Okay? You're still comparing 2 quantities. Okay? Comparing 2 quantities with different units. Okay, this should be more familiar to you. A rate. By the way, that's a T. Let's see. 50 miles per hour. 50 miles every 1 hour. 3 pounds for every 2 inches. Right? Again, usually you're measuring something, okay? You're measuring something, counting, right? Etc. There's something, okay? Something going on, but 2 different units. Okay? So, again, a question to consider on the quiz. How is a ratio different from a rate? Okay, consider that for these 2. The answer's right here on the side. Write your own answer, of course. The other definition, the other word we have to worry about is unit rate. Okay. It's a rate. Again, if you already know, it kind of builds, if you see, I don't know if you already see what's going on. A ratio is the big idea. A rate is a special kind of ratio. And I'll put that on the side. Okay. So all rates are ratios, but not all ratios are rates. Okay. I'm not going to write that down. You can write it down if you want. Unit rate. It's a rate written like a fraction. And actually, if you think about it, a regular rate can be written as a fraction. Same with a ratio, right? They can all be written like fractions. But there's a special case with unit rate, written like a fraction with denominator of 1. Okay? Let me give you some examples. 5 feet for every 1 second. And by the way, there's a special way to say it. I'm not doing it yet, but I'll tell you right now. Okay? And I used this example before, but think about it. 30 miles for every 1 hour. Denominator is 1. Okay? You know what? Let me, real quick. Unit has prefix of uni. And uni equals 1. You know, unidad, 1. Unicycle, 1 wheel. Okay? So, again, look what happened. We're going from a big idea to a more specialized idea to even more specialized idea. Okay? Unit rate, written like it's a rate, written like a fraction with a denominator of 1. Okay? Let's keep going. Let's work on some example here. Okay, but let's not forget something. Let me just write this right now because I'll forget otherwise. Remember, all ratios. You know, it's funny. I'm thinking the right answer in my head and I write something different. All rates are ratios. Okay? Just remember that. All right, let's do an example. This is page 32. Number 1. Okay. It says, Samantha picked 45 oranges in 5 minutes. Write this rate as a unit rate. Okay, as I said before, always write down what you're comparing and write it in the order it tells you. Samantha picked 45 oranges in 5 minutes. 45 oranges, 5 minutes. Okay, before we do anything else, this is a rate. This whole thing is a rate. How do I know? A rate because you're comparing two quantities with different units. Okay, keep that in mind. A quantity of oranges per minute. And again, minute, you're measuring something. That's usually what happens when you have a rate. You're measuring something, either distance, time, length, amount of some kind. All right? While I'm here, actually I should fill this in right now. I was going to wait till later, but why wait? Okay, if you can imagine, we have ratios. And in that world of ratios, we have rates. And in that world of rates, you have unit rates and unit price. UP and UR. Okay? More on that later. But these are rates and rates are ratios. Okay? Alright, anyways, back to this. Alright. just like in lesson 2. You have to see if you can simplify. Oh, by the way, again, I can see where someone's going to have problems with this. Ratios are not fractions, okay? They behave like fractions. You're comparing oranges and minutes. It's two separate things. You're looking at the relationship. You're looking at the relationship. It's not a fraction, okay? Just reminder. Ratios only behave like fractions. Never forget that. They're not fractions. Okay? So it's okay to have a bigger number on top and a smaller one on the bottom. Okay. What I'm going to say now, you have to see if you can make these numbers smaller. Since we want a unit rate, right? That means the denominator has to be 1. In other words, 45 oranges every 5 minutes. 45 oranges every 5 minutes. Yes? We want to know, well, how many oranges do you get in 1 minute? Now, you're like, wait, what do you mean by oranges? Just in case you forgot, oranges minutes. Remember, this person is picking oranges, okay? Samantha picked 45 oranges in 5 minutes. That's why the unit makes sense here. This lady's picking oranges. She picked 45 oranges in 5 minutes. The question is, how many did she pick in 1 minute? Okay? You have to see if you can simplify this. Okay? Now, here's the deal. To go from 5 to 1, to get rid of it, you divide by the number itself, right? If you want the quotient to be 1, the only way for that to happen is to divide the number by itself. Okay? Again, it's just a rule. If you have 3 and you want the quotient to be 1 when you're dividing, you divide by 3. If you have 99 and you want the quotient to be 1, you divide by 99. You divide by the number itself. It's just something you have to remember. Okay. Now, whatever you do to the denominator, you do to the numerator. Again, I'm using vocabulary like a fraction because they are acting like fractions. Okay, just remember that. Okay, the answer is 9 to 1. Again, I'm not going to do all the work. This builds on what you learned in lesson 1, finding GCF and LCM, and this builds on lesson 2, how to break down, how to simplify ratios into something smaller. Okay. Now, just for the sake of argument, I'll show you one last time how I got the 5. Okay. We're looking for the GCF. Well, here's the deal. If you do the 5, you know it's prime. Chances are it's going to be 5, but let me do the work anyways. Okay. Looks like the GCF is 5. Okay. 1 and 5. 1 and 5. That's where I got this from. Remember what this means. This means you're making 5 groups. 5 broken into 5 groups means it's 1 per group. Again. One. Okay? If you're breaking this into 5 groups, you have to break the 45 into 5 groups. Just remember what you're actually doing here, what this number means. You're breaking it up into 5 equal groups. Okay? That means each one is 9, 9, 9, 9, 9. Right? Because 9 times 5 is 45, right? 9 times 5 is 45. So this means, and again, now you have to write a sentence out of this. This person picked, now I'm going to rewrite the ratio, or the rate, excuse me. Well, it's also a ratio, but it's a special kind of ratio. This is a rate. 9 oranges per minute. And you know, you see me use that word per? Per. Okay. 9 oranges per minute. Now, you notice I didn't say per 1 minute? By definition, this word per means 1. 9 oranges for every 1 minute, okay? 9 oranges for every 1. For every 1. Goes together. So, you know what? Let me use a different color, because I do have other colors available to me, but I keep using pink. Oh, that's going to look weird, but that's okay. 9 oranges per minute. Per means for every one. And there's your answer. All right. Now I'm going to go ahead and do the got it's. This is page 32. Letter A. Amma downloaded 35 songs in 5 minutes. How many songs did she download per minute? Okay, again, in the question itself, there's that word per. Per. In the end, you're going to have a ratio or a rate with a denominator of 1. Okay? So, again, please write down the words. Songs per minute. Songs per minute. We know she downloaded 35 songs in 5 minutes. All right. We look for the greatest common factor. Actually, in this case, when we're finding the GCF, when we're finding a unit rate, we don't need to find the GCF. We already know what it's going to be. Why do I say that? In the end, we want the denominator to be 1. So, I'm going to say this in Spanish. A fuerzas, brute force, you have to divide by 5 to get rid of the 5. And that means you do the same thing here. Again, 35 broken up into 5 groups means each group's going to be 7. How do I know that? Because 7 times 5 is 35. Again, if I go backwards, 7 times 5 equals 35. Okay? And just again, if you want to verify, 1 times 5 is 5. Okay, 7 songs. Now here's the deal. If you write the words along with the final answer, all you got to do is write what you already have. I mean, look. Let me show you what I'm talking about. By following some patterns, you can make the work easy for yourself. The final answer as a sentence is 7 songs per minute. Again, that per is that 1. You're like, what's he doing now? It's this. Seven songs. So, if you trust me, if you follow my directions, you can see what I just did. Let me remind you, or review real fast. 35 broken up into 5 groups means each group's going to have 7 songs. 5 broken up into 5 groups means you're going to have 1 group of 1, or 5 groups of 1 minute. 7 songs per minute. The 1 goes with the per. Per minute goes with the denominator. The numerator is the top part. 7 songs. 7 songs. All right. Letter B. I think I should raise it up a little bit. There you go, so you can see. Jonathan is baking several loaves of bread to sell in his bakery. He used 9 cups of water and 12 cups of whole wheat flour. How much water was used per cup of flour? Okay, again, write down the words. Water per cup of flour. Water per flour. Okay. It says here he used 12 cups of water. Oh, excuse me. Whoa. See, I'm going too fast, people. Don't go too fast. 9 cups of water to 12 cups of flour. Okay. Now that makes more sense. Okay. All right. We want a unit rate. So the denominator has to be 1. Okay. I'm going to do something I didn't do with the other problem because I want you to see something. What you're really doing here is 2 separate problems. You're doing 2 separate problems. Do not confuse the 2. There is a connection. They are connected, but be aware of something. Okay. We want the denominator to be 1. We have 12. To go from 12 to 1, you're going to divide by the number itself. In other words, we have one big group of 12. We're going to break it up into 12 groups. We're going to break it up into 12 groups. That means it's groups of 1, right? That should make pretty good sense to you. Now, here's the deal. This is where it gets weird. 9 divided by 12. Okay. This is the weird part. You're not going to get a whole number. Okay? You're going to get a fraction. All right? What's going to happen is you're going to have to write this. 9 over 12 per 1. No, but here's the other part of this. It's a little weird. You're like, what? Just for now, just watch what I'm doing. I will explain what's going on in just a moment. Okay, we have 9/12 over 1. This is obviously flour, 1 cup of flour. And this, you know what, you can't leave it like that. Always, when you're working with fractions or ratios, if you can simplify, or rates, if you can simplify, make it smaller. So now you're just focused on this. The bottom part's done. Now you just got to worry about the numerator. The 9 and the 12 have a common factor of, I believe, 3. Okay. By the way, this is water. I'm just putting there just so I don't forget for later. Now that means 3/4 water, 1 flour. Now you're like, wait, that doesn't make any sense. Let me rewrite this. Okay. It's always good to use the units of measurement. So 3/4 cup of flour. Sorry, cup of water. See, I caught my mistake because I saw what I wrote. For every 1 cup of flour. All right. Now, let me just finish this problem, then I'll explain this part, because I know some of you are like, I don't get it. You will. You will. Okay? All right. Here we go. Jonathan... I don't know if I did. I'm combining 2 words. Jonathan used 3/4 cup of water for every cup of flour. Of course, you could have used the pattern I used before. You know what? Let me just erase this. See, this is why you don't use pen, people. If I'd used a pencil, I could have erased it very easily, and now instead I got to use a little whiteout. Okay, anyways. There you go. You could have said, like in the other examples, 3/4 cup of water per 1 cup of, or per cup of flour. Okay, I'll even do that here on the side, and I'll do it in pencil. 3/4 cup of water per flour. Okay. And again, just like I did before, the per goes with the 1. And you know what I forgot? Always use the unit of measurement per cup of flour. It's okay to have a fraction in a ratio. Again, don't overthink this. You're like, how does this work out? What just happened? Okay? What happened was, now you have to understand the idea. Over here, way back in the beginning. This is bigger than this. Obviously, 12 is bigger than 9. There's no way you can divide it evenly and get a whole number. You're going to get a fraction. How does that work? You break the 9 up into parts. Okay? That's what actually happened. Now, if you had covered fractions, it should make sense. But if you didn't cover fractions, then you're like, how did that work? I'm going to give an example here on the side. Hopefully I have space. Okay? Here we have a dollar bill. A dollar bill. On this side, I have 4 kids. Again, I'm not an artist. All right. $1 for 4 kids. Now, here's the deal. You can't tear this up. You can't tear this paper dollar bill up, right? If you have to split this up among 4 students, what has to happen? You break this into parts, but not literally. What's going to happen is you're going to change this either into 10 dimes or 20 nickels or 100 pennies, or actually the easiest thing would be 4 quarters. So this won't make sense if you're not watching the video. So please pay attention to what I'm saying. All right, here's the deal. We have 25 cents, 25 cents, 25 cents, and 25 cents. We still have the 4 kids. All right, you should be able to see if a question is, how much money does each kid get? You should be able to see each kid gets 25 cents. See, yay, use pencil. Each kid gets 25 cents. You should be able to see it. I mean, look, each kid gets a quarter. 1 for him, 1 for him, 1 for her, 1 for her. Right? You could be able to see that just intuitively. You look, oh, okay, $1 for 4 kids. I changed the dollar into 4 quarters, right? I split it up into parts basically in a way, and then I shared equally. Now, with this cup of water, right? It's the same idea. You took that cup, and you know how measuring cups. Here, let me see if I can use another page and you can see what happened. Just to continue the idea, because you really have to understand this idea. And this is where it's going to take a while. You know what? I'm just going to draw regular rectangles instead of trying to draw measuring cups. That'll take way too long. Okay. 9 cups. And you have to, and again, you have to split it into 12 cups of flour, right? Okay. So you have to go from nine of these into 12 of these. Okay. So water. $12 cups of flour. I guess I'm trying to teach you a couple things here. If you understand the idea of fractions, if you've seen it before, this should make sense. And so I'm going to try my best here just to give you a real quick preview if you haven't learned fractions yet. 12 cups of flour. What's going to happen is, just like with the quarters, you're going to break this up into 4 parts. Why 4? It doesn't have to be 4. You can break it up into any number. Basically, at this point, you're going to look for the least common multiple of 9 and 12, right? And the least common multiple is 36, right? I know, I'm just going to say it. You may not get it, and that's okay. When we get to fractions, we'll come back to this. It'll make sense. But basically, 9 and 12, LCM, right? 9, 18, 27, 36, 45, 12, 24, 36. Okay, but what does that mean, 36? That means I have to have 36 parts. 36 parts, right? To go from 9 to 36, to go from 9, and please, if this doesn't make sense to you, that's okay. We'll get to it. We'll get to fractions. You have to multiply 9 by 4 to get 36, right? That means each of these, 1, 2, 3, 4, becomes 4 parts. And again, I apologize if it doesn't make sense. If you understood fractions, if you've seen it before, this should make more sense to you. If you haven't, I can understand why you're confused. That's 1, 2, 3, 4, 5, 6, 7, 8. One more. 1, 2, 3, 4. Okay, perfect. If there's 36 parts here, right? That means if I have 12 on this side, 12 cups of flour. To go from 12 to 36, that means they get 3 parts. This gets 3 parts, okay? And look, please bear with me. Again, I'm showing it to you. It may not make any sense. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 3. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. There's a connection there. Again, when we get to fractions, this will make sense. But if I confuse you more, let's just go back. I'll review that one problem real fast. Look, all you have to understand is this. Don't overthink it. Water, flour, cups of water, cups of flour. 9 cups of water, 9 cups of flour. I want the denominator to be 1. I divide by the number itself. 12 divided by 12 is 1. 9 divided by 12, just write it like a fraction. 9 over 12. 9 over 12. Simplify that. You get 3 over 4 over 1. So this is a cup of water, right? 3/4 cup of water per cup of flour. 3/4 cup of water per cup of flour. How does this work? The only way you can the only way you can divide a smaller number by a larger number is if you break the smaller number into parts. You're going to get a fraction as an answer. Okay? Just please understand that. Don't overthink it. Anyways, let's keep going. All right, letter C. This is the got it, letter C, page 33. Letter C. Now, here's the thing with letter C. You kind of have to look at the previous stuff that we did before. Okay? So let me read this first real fast. An adult's heart beats about 2,100 times every 30 minutes. A baby's heart beats about 2,600 times every 20 minutes. How many more beats does a baby's heart beat in 60 minutes than an adult's heart? Okay. Let's look at letter C. Actually, might as well put it back. A hummingbird's heart rate while resting is about 7,500 beats every 30 minutes. How many more beats than a hummingbird's heart beat in 60 minutes than a human baby's heart? Okay. We're doing 2 rates here. We're comparing 2 different things. We're comparing a hummingbird to a human baby. Okay? We're talking about heartbeats, right? Now it says here, according to the way the question's phrased, how many more beats does the hummingbird's heart beat in 60 minutes than a human baby's heart? So it's saying a hummingbird has more beats per minute than a baby heart. But by how much? Okay? Alright. So just for the sake of being complete, I'm not going to draw pictures. I'm sure you know what a hummingbird looks like. We're comparing a hummingbird and a baby. And what are we comparing in both of them? We're comparing beats per minute. Beats per minute for a hummingbird and a baby. All right. Now for the hummingbird, we know, according to the problem, it's 7,500 or 7,500 beats for every 30 minutes. Okay. Now for a baby heart, what do we have? A baby's heart, let's see. A baby's heart, and again, where am I getting this from? Just so you know, they're not just pulling this out of the air. A baby's heart beats about 2,600 times every 20 minutes. All right. 2,600 beats per 20 minutes. All right. This is where it gets a little crazy. For both of them, we want to know what it is for every 60 minutes. For every 60 minutes. Okay. So I'm going to have to rewrite this a little differently. Just bear with me here. Hopefully write it a little neater. 7,500 for 30 minutes, but we want to know how much it is for 60 minutes. Same thing with this. 2,600 every 20 minutes, but we want to know what it is for 60 minutes. All right. If you know your times tables, how many 30 do you need to get to 60? You multiply by 2. Whatever you do to the denominator, you do to the numerator. All right. 7,500 times 2. All right. 15,000. Okay. How many groups of 20 does it take to get to 60? You need 3. Okay, same thing here. Guys, I realize this might be a little harder for you guys because you may not know how to multiply or you didn't learn. Just bear with me, okay? You can do this. Don't give up. Look. 2,600 times 3. Again, multiplication is just repeated addition. If you forgot how to do this, it's the same thing as saying 2,600 plus 2,600 plus 2,600. Just for the sake of argument, I'll do it this way. So you can see what's going on. 0 plus 0 plus 0, 0 plus 0 plus 0. 6 plus 6 is 12, plus 6 is 18. All of you can add, so you can do this. 2 plus 2 plus 2 is 6, plus 1 is 7. Okay, 7,800. Now I'll do it here, and you'll see we get the same answer. 3 times 0 is 0. 3 times 0 is 0. 3 times 6 is 18. Carry the 1. 3 times 2 is 6, plus 1 is 7. Same answer. A little sloppy, but this one is anyways. Now then the question's asking, how much more? How many more beats does a hummingbird's heart beat in 60 minutes than a baby's? You can see that this number is bigger than this. Now, how many more beats means you're going to have to subtract. Okay? And just for the sake of argument, I'm going to use pencil. Because if I mess this up, it'll be harder to erase. Minus, you line up the place values, ones, tens, hundreds, thousands, 10,000s. Okay, 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 8. You can't take away 8 from 0. Well, in this case you can't. Okay, but when we get to negative numbers, you'll see that it is possible, but that's for later. Okay, so we're going to regroup. We're going to break this thousands apart. Okay, you know what? I'm going too far. When we get to chapter 3, I'll explain what I mean by that. We're going to regroup. We're going to break this. We're going to take away 1 and put 1 there. And I'll explain to you why that works, okay? But for now, just remember what you were taught by your elementary school teacher, okay? Because really what you're doing is you're borrowing, you're regrouping, you're breaking this up, and you're taking... Okay, you know what? I'm making it too hard. Let's just keep it simple. You take 1 away from the number next to it. That 1 you took away, you put it there. 10 minus 8 is 2. 4 minus 7. Again, you can't do it. You take 1 away from this, you have 0, the 1 is there. 14 minus 7 is 7. Your answer is 7,200. But A number on its own means nothing. On the quiz, you must tell me what that number means. The 7,200 means a hummingbird heart beats 7,200 more per minute. You know what? Why did I add the per minute? That was wrong. I apologize. It's not a unit rate we're looking for. It just means that a hummingbird heart beats 7,200 times more. Right? That's it. Done. And actually, does that sound right to you? Sounds a little off, right? I know I tell you guys, if it doesn't sound right, a hummingbird heart beats 7,200 more what? So let me just put times. Oh, now that sounds much better. All right. And now we're up to goal number 2. I know it's already up to 41 minutes. Guys, thank you for hanging out so long. But better that I'm doing this in the video as opposed to in the classroom, because there's no way we could have done this in Zoom. If I wait for you guys a copy, just no way. All right. Goal number 2. Don't worry, we're almost done. Goal number 2. Find a unit price. Okay. Let me just... But what's the unit price? Okay. Let me just put it this way. A unit price is a special kind of unit rate. Yes? And saying what I just said right now, you know what? I'm going to make a correction to what I did earlier. Okay. I hope you did it in pencil. All right. All rates are ratios. Then you have rates. And then for rate, you have unit rates. And then inside unit rates, you have a unit price. So, I'm going to highlight this, darken it a little bit so you can see. There you go. Much better. Still sloppy, but you know what? It's always good when we catch mistakes to fix it. Because I said these two are kind of separate, but really, this is actually part of this. A unit price is a special kind of unit rate. A unit rate is a special kind of rate, and all rates are ratios. Okay? And you can also say rate is a special kind of ratio. That's fine too, if you want. Okay, anyways, back to the unit price. Unit price is cost per unit. But what does that mean? Cost per unit. Blah, 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 blah. Cost per unit. What does that mean? Once I give you the answer, like, that's it? Yeah. Yeah. Feynman technique, people. Keep it simple. Cost per unit means it answers this one question. It tells you how much one of something costs. That's it. Cost per unit. How much for one? Let me write that question. How much for one? Really, that's all it is. Unit price. How much for one? Right? Let's see. 8 bagels for... No, wait. You know what? I'm going to do this anyways. How much for one? The way I set this up, will this tell me how much one costs? Right? Will it? I can divide by 2. 4 bagels for $1. You're like, wait, that kind of tells you how much $1 gets you. Gets you 4 bagels. But that doesn't tell me how much one bagel costs. So, wrong way to do it. Wrong way to set it up. It really is. So how do you set it up? Set up a unit price with money as numerator, right? Let's try that problem again. $2 for 8 bagels. Right? How much for one bagel? Let me put this question on the side. How much? This might help you a little bit per bagel. Again, there's that per. Per. What am I doing? I'm looking for my blue highlighter. Apparently it disappeared on me. Per bagel. Okay. We're going to divide by 8. Why? Because I want to know the price of one bagel. $2 divided by 8. Again, I can already see you guys' head exploding. $2 would be 8 quarters. 8 quarters divided by 8 is basically 1 quarter. And again, you'll get to that point where you can do that kind of stuff in your head. So basically, $0.25 per bagel. Again, if you don't understand where I got the fraction from, people, you are in trouble. But when we get to fractions, I hope it makes sense. But you know what? Just for sake of argument, I'm going to show you the math. $2 divided by 8. Nope, I'm not going to have space to do it there. I'm going to do it way up here. I hope you can follow along. I can't make groups of 8 from 2, so I put a 0 there. Now it's 20. I can make 2 groups of 8, which gives me 16. 20 minus 16 is 4. I bring down the 0. I have 40. I can make 5 groups of 8 from 40. That's 25 cents. That's where I got the 0.25 from. But again, I just know for a fact, $1 is 4 quarters. So if I have $2, that's 8 quarters. 8 quarters divided by 8, 1 quarter, 25 cents. All right. Anyways, the point of me showing you this is that when you set up a unit price, the money should go on top. The amount should go on top as far as money goes. Okay? And I believe that is it. I will do one more. Hopefully no fractions, because again, I'm not here to test you on fractions, not yet. So if you're worried I'm going to put that on a quiz, I will not. I'll make certain that I don't put fractions on the quiz this coming Friday. All right. This is page 44. This has been the longest lecture yet. Page 34, number 4. This is the example, not, I'm going to put that down. It's not the guided practice. Example number 4. 4 potted plants cost $88. What is the cost per plant, or what is the price per plant? Okay, 4 potted plants. Let me show you a picture because maybe you don't know what that is. This is a potted plant. It's a plant in a pot. So 4 plants in a pot cost $88. And you know what? Let me do pencil. 4 potted plants are $88. Right? Okay. What is the price per plant? So price per plant. Let me write it a little differently if you can visualize this. Price per plant. The price is $88. Again, put the money on top. Per plant, we have 4 of them. Find the GCF. Okay, you know what? If you don't know what the GCF is, but you know you can divide by 2, then just do that. But it should be the GCF to make it easier. But this works too. 88 divided by 2, 88 broken up into 2 groups is 44. 4 divided by into 2 groups is 2. Now again, you have 2 even numbers. You can divide by 2. Again, the goal is to get 1 in the denominator. And now you have $22 per 1. Okay. So how does this work as a sentence? The cost is $22 per plant. And that's your complete sentence. On this next quiz, you're going to have to write the complete sentence. I won't do the sentence frame anymore. Or you know what? I might for some and for others, no. So you really have to understand what you're doing as far as the English goes. Okay? Let me do this again. $88 for 4 plants, right? We want the cost of 1, right? The denominator is going to be 1. So to go from 4 to 1, you divide by the number itself. And if you do division, you're going to get 22. Let me do the division anyways, because some of you might, I don't understand where you got that. And if you don't know how to divide, please look it up on YouTube. Okay, I can't do 2 lessons at once right now. And I feel bad that you didn't get this last year, but you know what? It's not on me. I can only do so much. You got to help yourself at some point. Okay? All right, and that's it. Good luck. This was the longest lecture yet, almost an hour. Good luck.